Okay, stats, here's packet day 2. This is, I'll just kind of give you a brief overview of what we're going to do today. This is all chapter 3 stuff. And it's going to go from here to, we're going to do this day 2. Day 3, we'll wait for day 3 to do percentiles. So this bottom half of the second page, we'll wait to do that day 3, okay? So we got like a page and a half to do today, box and whisker plots on the front side, and some empirical rule stuff. So if you guys have your laminated sheet of this and you want to get it a bigger one, you can sure do that. But I listed it here as well. If you can see, those percentages, great. You wouldn't need to have your laminated sheet out. But if you have a laminated sheet and you want the bigger one, you go for it. Okay, let's talk box and whisker plots first. I'm going to go through this information and then I'll just let you do this one on your own. But I went ahead and threw out some stupid hypothetical numbers up here just so that you can kind of see. And I'll do the 5-number summary and stuff with those hypothetical numbers and all that good stuff. And there you go. So mean, I'm not going to go ahead and find the mean for this one, but the mean is the average. So add all the values up and divide by the number of numbers that you have. The median is the middle number. Okay, so I'm going to go ahead with my hypothetical data here. I'll zoom out so if you want to write that down, you can. The median is the middle number. So I'm going to do that over here when I go to find my 5-number summary. Okay, so if I do that now, the median, the middle number, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, which means I will not have an exact middle number. My middle number will be split between the first 5 numbers and the second 5 numbers. So there's 5 here and there's 5 here, which means my 2 middle numbers are 8 and 10. And so I find the average of those two when you have 2 middle numbers. So my median is actually going to be 9. The average of 8 and 10 is 9. All right, my minimum number is 2. My maximum number is 22. Those are just from these guys here, okay? Then for my 5-number summary, I'll finish doing this part. 5-number summary, I need a Q1, which is my quartile 1 and quartile 3, okay? So if I'm looking at this data set right here, like this information, I'm looking to find the middle of those, which is going to be this value of 6 right here, and that's my Q1. Then I go and do the same thing over here with these 5 numbers, and my Q3 is going to be 15, which is this number here. So there is that, okay? If I make my box and whisker plot off of that, I'm going to first start by making a number line here. So I'm going to go 0 to maybe 25, I don't know. I'll go 5, 10, 15. Hey, that wasn't terribly spaced out. 5, 10, 15, 20, 25, okay? So whenever you're making a box and whisker plot, I always start with a ruler. I did that down below here so you have a scale to draw because it always drives me crazy when I have this going on. I think I draw this every time we talk about box and whisker plots. This drives me nuts. 0, 95, 98, 99, and 100. Don't write this down. But I've literally seen this happen before. This looks symmetric, but obviously these numbers are not symmetric. So that's why I have you go ahead and write a ruler down below here and label your ruler so that you don't do stupid crap like this. Okay, don't do that. All right, so make sure your labels are nice and good. Okay, so there's my ruler down below here, and if I make a box and whisker plot with this guy, I'm starting at 2. There's my first dot. 22 is my second dot. And then I have 6 here, 9 here, and 15 here. So there's my box and whisker plot. You don't have to necessarily write this out if you don't want to, but that's what he would look like with my hypothetical numbers that I've made up here, okay? 5-number summary and box and whisker plot. There he is, okay? All right, I'll keep that on the same page, but I'll go back over here to the mode. The mode is the one that occurs the most, and in this case, I think I only have one mode, and it is 6. 6 is showing up twice. If you don't have any of them that show up more than once, then you have no mode. The range is the biggest minus the smallest. So largest minus the smallest, which in this case would be 22 minus 2, so 20 is my range, okay? All right, mid-range is one that people forget all the time because they don't remember what mid-range was, so I'm going to put a little star by it. Mid-range is Q3 minus Q1, or in other words, it's the length of the box. Box length. So it's like, how wide is this little box right here, okay? So since Q3 is 15 and Q1 is 6, I'm trying to find like the distance of that box. So 15 minus 6, which is 9. That's going to be my mid range. It's the middle range. The range of your middle, basically, Q1 to Q3. And then the last one is standard deviation. I'm not going to make you calculate the exact standard deviation because we're going to use what's called the rule of thumb, okay? The range, or the standard deviation rule of thumb, is taking the range and dividing by 4, okay? And that doesn't give you the exact standard deviation, but it gives you a number that's awfully close to what the standard deviation probably is. So in this case, my range was 20. And I'm going to take 20, and that's really nice. Look at that. Hypothetical numbers. Look at me go. I came up with some really nice hypothetical numbers. 20 is my range. If I divide it by 4, I get a standard deviation of approximately 5. Now, if I calculate the exact standard deviation, it's probably going to be a decimal, but it might be close to 5. So that's how you do the rule of thumb for standard deviation, okay? All right, you're going to be doing those same things with the height data. Okay, and then you're going to be doing a double box and whisker plot with height and wingspan. We're going to look at the box and whisker plot for height versus wingspan, and how you're going to do that is you're going to have one box and whisker plot here and one box and whisker plot like here. So you're going to do one on top of each other. So like height would be this first one and wingspan would be the second one. So that's how I want you to set that up when you go to do your box and whisker plot. It's a double box and whisker plot. You put them on top of each other. Make sure you label this scale according to what you want. I don't know if you go by 5s or 10s or whatever you need to do, but there's that. Okay, so find your 5-number summary first. Do your box and whisker plot, but one on top of each other. Okay, all right, next thing. Ooh, let me erase. Okay, next thing. If you need to pause and go back through and listen to this again, that is totally fine. Okay, next thing is the empirical rule. So that person that came up with this, they crunched a bunch of numbers and they said, okay, if you know the standard deviation, which is S, and you know the average, which is X bar is the average or the mean, and S is the standard deviation, okay, what should happen is that if you add one standard deviation or subtract one standard deviation from the average, this is the average, if you do that, about 68% of your data should live in that range, okay? If you add it again and subtract it again, about 95% of your data should live within that range. If you add it again and subtract it again, 99.7% should live in that range, okay? And individually, I can say 13.5% is going to live between this value and this value, etc., right? So like if my average is 85, and let's say my standard deviation is 5, 85 would go here, this would be 90, 95, and 100, okay? Because I'm adding 5 every time, or I'm subtracting 5, so 80, 75, and 70, okay? So I can look on this empirical rule and say okay, what percent of people should be between a 75 and an 80? 13.5%. Should approximately be in that range, okay? So that's what you're doing for the most of this top part here. And then the last thing is calculating z-score, okay? So z-score, again, is, let me erase all this stuff, okay? So if my average is 85, that has it's basically at the 0 station. If I add one standard deviation, this is a +1, this is a +2, and a +3. This is a -1, -2, -3, because it's like I've subtracted it once, subtracted it twice, subtracted it 3 times, right? So if I have the score of a 70 exactly, my z-score, if I'm at a 70, my z-score is exactly -3. Okay, that's where I'm at. If I am at a 90, my z-score is +1. That's where I'm at. Now, the deal here is, let's say I am at a 98 right here. Let's say I'm at a 98. Okay, what's my z-score? Well, it's going to be some decimal number between 2 and 3. But here's how I find it. My value, this is me, and here's the average. And then I'm going to divide by the standard deviation, okay? So if I'm 98, the average is 85, and the standard deviation is 5, I would take and subtract those. 98 minus 85 is 13 divided by 5, which is 2.6, Okay, so my z-score is at 2.6, which is what we said, approximately between 2 and 3. Okay, so that's how you calculate z-score. They're going to ask you a question down here for that. All right, so I'm just going to get you started on like number 11 real quick, and then you can take it from there, and I'll let you go through the rest of it. We're going to stop here, so don't do anything below that box. But just answer the rest of those questions, okay? So the average pulse rate for your class, X bar, average and standard deviation. Where do you find that information? From the table. Average pulse rate. Pulse rate is here. Average is 65.5. Standard deviation, we'll go 2 decimal places. 11.3. Well, we'll go 1 decimal place. I'll cut you some slack. We'll go 11.3. So 65.5 and 11.3 is your standard deviation. Let's see if I can remember that before we go down. 65.5 and 11.3. There we go. Okay. Fill in the following bell curve. Okay, I screwed up. I didn't give you a bell curve, so you gotta do it off to the side over here. Make yourself a bell curve and fill it in. So do the 0, do the 1, do the 2, do the 3, -1, -2, -3. Okay, so fill those in, fill in those values, adding and subtracting your standard deviation. Okay, so fill that in off to the side over there because I dropped the ball and I didn't put it on there. All right, a couple questions and then I'll set you free. The range of values that are within 1 standard deviation are this guy and this guy. 1 standard deviation would be this number and this number, okay? So we're trying to figure out what those 2 numbers are. List them here after you've added and subtracted, okay? Next, what percent of the data should live within there according to the empirical rule? What percent of values lives between here, okay? If I go back up to my bell curve, what percent of values should be, according to this, between there? 68%. There you go. I'll answer that one for you. Now, C, though, says what percent of the students in our class actually had pulse rates within that range. So what I want you to do is go back and use this range and figure out how many people out of, I think there's 14 in your class, how many people out of 14 actually live in that range, and see if it's close to 68%. Might be way off, but we'll see. Okay, and then do the same thing for D and E and F and G and all that good stuff. Okay, so those are just answering questions on. Got it? Everything else should be pretty straightforward, and just do that page and a half for your day 2 stuff. There you go. That's all I have.